Okay, so today we are in Unit 1, Lesson 1, the follow-up example on domain. I asked you to complete A through D. All of these should be done algebraically, which means you look at the equation, you apply the rules, and then you come up with your answer for domain. The first answer that we have is negative infinity to infinity. Would anyone like an explanation? Awesome. Second one. Second one ends up, and the answer includes 3 separate intervals because there are 2 breaks in the number line solutions. The first break is going to be at positive 3 and negative 3 is the second. That comes from factoring the denominator and determining what x is not allowed to be. Any questions on B? Totally free, no charge. Yes. Yes, did you factor the denominator in B? Yes, so you got positive and negative 3. Okay, if you do the square root method, if you say x squared minus 9 cannot equal 0, it's weird to write equations with cannot equal, I know that, but it's solved the same way. And then when you take the square root, remember, 2 solutions plus or minus, if you use that method. All right, letter C. Letter C was simply take what's underneath the root, set it greater than or equal to 0, solve the linear inequality, write the resulting interval. Make sure you use a bracket because this would be greater than or equal to, which means it's an inclusive solution. And then letter D is the combination of both of these ideas, setting up a number line using open circles to exclude denominator values, but then also restricting the interval based on square root. So the final solution that I have is from 3 to infinity. Any questions on that? Explanation needed. Yes, ma'am. Well, what happened was when you restricted, you started in the top and you took the entire number line and you restricted it from 3 on. You've already eliminated half the solutions. The solution over here of negative 6 has already been eliminated. Okay, so it would just be a further elimination if it if it could be found in the region that still existed as solutions. All right, the very last example is on the difference quotient. This is something that is the fundamental idea to, well, it's the fundamental idea to derivatives in calculus. It is the formal definition. It explains a whole lot, but in order to understand it, we have to break it down into the notation and the nuts and bolts of it. So the first thing I want you to recognize is that they give you and always define a function. The function in this case is going to be x squared minus 2x plus 9. You are then going to have 3 pieces to figure out. F of 3 plus h minus f of 3, all of which is over h. So what I'm writing in black are non-negotiables. They have to stay there and be present. We're going to substitute the red. We're going to substitute the green. Why do you think at the end they have this disclaimer that h cannot equal 0? Because you can't divide by 0. So it's taking into account, hey, no matter what, h can never be 0 from the get-go when you're calculating this. It's a restriction. So I'm going to come over here, and I'm going to start with the red, and it says here, go to the f function, and every place I have x, I'm going to replace it with 3 plus h. So this x and this x are going to come out, and it's going to give me the following. X comes out, I'm going to get 3 plus h squared minus 2 times 3 plus h plus 9. This is that same red box written out. Then I have my subtraction sign. And now I'm going to do f of 3. So I come back to the same function. Every place I have an x, I'm going to replace it with a 3. So I'm going
going to get 3 squared minus 2 times 3 plus 9, all of which goes in that green box. And then I have my division by h.
Yes. I'm sorry? I do not. I might have mine. Did I give you one? Okay. I didn't give you one. All right, so once we do the setup correctly, now we have to go back and do all of the algebra. And this is where what we did in the prerequisite becomes really important. Minding your parentheses, using PEMDAS, etc. So, if I quickly do this, it's going to give me 9 plus 6h plus h squared minus 6 minus 2h plus 9 minus 9 minus 6 plus 9. Now this, I'm going to put in a box for a reason. Okay. The reason is because on your prerequisite test especially, some of you are still making the same mistake. When I have this subtraction sign up here, I want the subtraction of f of 3. F of 3 has to be completely simplified down to one value. So really, this should probably take on parentheses here and here. The value of this quantity ends up being what? 18 minus 6, which is positive 12. But then I want to distribute the negative to that positive 12. Again, all of this is still over h. From here, I want to combine like terms. So I have my h squared up top. 6h minus 2h gives me 4h. 9 plus 9 is 18, minus 6 is 12. Minus 12 gives me 0, all of which is over h. Okay, so I'm kind of working in this direction here. And then lastly, how can I reduce h squared plus 4h? Can be reduced. Right. If I look up top, I can factor out an h plus 4. That cancels my h's, so my final answer is h plus 4. But remember, h can still never equal 0 because in the original problem I had a division. So the final answer is h plus 4. Yes, all of the difference quotients will be this long.